This video will give you a quick introduction to logical operators in R and then show you how to implement them in RStudio. The first thing that we're going to do is take a look at this table that I've built of the major logical operators that you're probably going to want to use or that you might come across if you're reading somebody else's code. So starting at the top, you can see that if you want to use a logical test to see whether something is less than something else, you would use this symbol right there, the less than sign. And so, for example, if we wanted to know whether 1 was less than 2 in R, we could use that symbol, and then R will return either a true or a false answer to us. So logical variables are unique because they look like they might be characters, but they're actually not, because if you look carefully, you'll see that there are no quotes, and both true and false are entirely written in uppercase. And if R sees something like that, it will understand it to be a logical variable. So that's the first example. Now let's say if we wanted to check whether something was less than or equal to, it's almost the same as before, except now we add an equal sign. So here you would be asking whether 2 is less than or equal to 2, which of course it is, and that would return a logical true. If you wanted to check whether one quantity was bigger than another, then you can use the greater than sign, just like I have here. And so here, 2 is greater than 1, which is true. Just like we saw with the less than sign, if you wanted to check whether something was greater than or equal to, you would just add an equal sign after the greater than sign. And so here, if 2 is greater than or equal to 1, you'll just come back with another true. Next, if you're using a double equal sign, R will understand that to mean a logical equality. Right? So if we have 2 is logically equal to 2, then it will return a true for you. So there's a difference between logical equality and assigning values using a single equal sign. So make sure that you use 2 if you're trying to run logical tests. Next, if you use an exclamation point followed by an equal sign, R will interpret that to mean not equal to. So you can see in the example, I have 2 is not equal to 3. And just like you would expect, that will return a true because 2 and 3 are different things. You can also do larger scale negation of whole expressions or variables or something like that by just using an exclamation point followed by either the expression or the variable that you're interested in. So here, and this is a little convoluted, but once you get used to it, you'll see it's pretty straightforward. Here what we're doing is we're testing whether 1 is equal to 2, logically, which is false, and then we're negating that, right? So not false, which in R would be true. And so really what you need to pay attention to here is that logical operations follow the order of operations generally. So you would work inside the parentheses to develop a true or false value, which would then go to this exclamation point to negate whatever that would happen to be. The last two expressions can be used often when you're trying to combine multiple variables. And so the first one is OR, which is just a vertical line, as you can see here. And so if we had this expression, which looks a little bit formidable, but you'll see in a second once you parse it, it's really not so bad. So as always, we're going to start inside the parentheses. So here we're checking whether 1 is greater than 2, which is false. And then on the other side in the parentheses, we're checking whether 2 is less than or equal to 3, which is true. So we have false over here and true over here. And if you're using OR, if either side of it returns a true, then the whole expression becomes true. So if you were to run this, just type it into R and check, you would see that the combination of false or true returns true for the entire expression. The final one is using the ampersand, so the and here. So you would write that as X and Y, or like this. This is how it would work, right? So again, working inside the brackets, 1 is less than 2, which is true, and 2 is less than or equal to 3, which is also true, and so true and true would return true. And so the difference between OR and is that for and, both sides of the operator have to be true, But for or, only one of the two sides has to be true. So if we go into RStudio, we can see really quickly how we can use these logical operators in a pretty straightforward way to pull subsets of cases. And so what I'm going to do to show this to you is just create a variable named x that is going to just get 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? So I'll just run that, and I now have x in my global environment. So the first logical test that we'll do is to check whether x is less than or equal to 5. Right? So you can see that I just typed x less than equal to 5. And so what this will do if I run it is return a series of true and false values that follow the same order as x. So the first true here is checking whether 1 is less than or equal to 5, which it is, so true. The second, whether 2 is less than or equal to 5, which it is, so true. The third, whether 3 is less than or equal to 5, which it is, so true. We don't start seeing falses until we get up to the sixth value. So here it's asking whether 6 is less than or equal to 5, which it's not. And so we get false. And that carries over for 7, 8, 9, and 10 too, right? So we get a few trues and a few falses depending on how we set up our logical test. Now, in and of itself, that probably doesn't seem very interesting, but let me show you something else you can do now. So I'm going to put x, I'm going to start some square brackets, and then I'm going to close them. And now I'm going to run this, and you'll see that now R is only showing me the cases where that logical condition was true. So it only is producing the first, second, third, fourth, and fifth case, right? And that just means that what R did kind of quietly was take all of the logical results returned by this test and is now only printing the ones where that logical condition is true. So if you wanted to make this a little bit more complex, you could say, let's say that you wanted the cases where x is less than 3, so 1 and 2, or the cases where x is greater than 8, so 9 and 10. And so if I run this, you'll see that I get 1, 2, 9, and 10. And hopefully this is the start of seeing how you can use these logical operators within larger data sets to produce some pretty specific and finely grained subgroups that we'll then use to learn both descriptive and inferential statistics. So it takes a little bit to get used to these if you haven't really tangled much with logical operators before, but if you give it a little bit of practice and use some kind of simple examples like this that you can develop yourself, you'll see that it's actually both powerful and relatively straightforward for as convoluted as it might look at the start.